I was so close, you guys. I almost got to the end of the slide, so just a couple more. So, to continue the discussion on how saltwater can be converted to fresh water, I already explained the distillation process up here in figure A. This bottom figure, part B, covers the idea of reverse osmosis. So you can see here that the water would be, the seawater would be brought in through area A here, and then you're going to have some kind of a mechanism up here that's going to be applying pressure to the water, even the water, just the water itself. Is going to have greater pressure affiliated with it the lower it's found, just based on the amount of water in that column. And then what happens here is this is a semi-permeable membrane. So think of, a wall with a lot of tiny little holes in it. And basically this water here is going to be pressured to push through that semi-permeable membrane. The fresh water will cross over and the little salt sediments are going to be left behind. So that's what all of these little black dots are, is salt being left behind. Once the water has been filtered, basically, the fresh water would then leave this chamber here in area 4, and the brine that was left over in the distillation process in area 5 up here would actually be in area 5 down here. So all of this is considered that salty, high salt concentration water that's left behind. And then what happens to the waste of that is always of concern, because like I mentioned in the distillation process, it can damage plants, animals, and do lots of wonky weird stuff too if you dump it in waterways or put it back into the ocean. And then this next slide, this last slide, is basically just where renewable water availability, how it measures across the globe. Those areas that are in the blue, light blue, medium blue, dark blue, those are going to be areas that water is plentiful or can be plentiful based on seasonal precipitation and at least the way that water is being captured and diverted in those areas. Those places are still able to get water to those people. It's these areas that are red, orange, and yellow, where water would be basically considered ultra scarce. So you can see in regions in Northern Africa, the Middle East, they're not selling bottled water for 99 cents in the Middle East. Water is considered a precious commodity, almost a slap in the face when they see water being sold for 99 cents in a bottle here in the States. So water is going to be very, very scarce in these areas, affecting, agricultural output and so on, basically non-existent. And then you get into the lighter shade of brown and yellow, and it's going to become scarce or just, better availed, but not to the point where those countries can consistently rely upon the water that's being diverted. Here in India, there's some major projects that are underway with the Himalayan mountain range up here. They're actually coming up with some more modernized attempts at diverting water from those areas to get it to other places in India on a consistent basis. But I'll let you kind of look at this. Russia up here, water is not an issue. China has a vast part of its country is considered desert. The Taklamakan Desert is a huge desert area, so low precipitation in those parts. Our neighbor to the north, Canada, they're not worried about water availability, at least not at this time. And that ends this particular module.